Section 2.7, Square Roots. The essential question for today is, how do I use my knowledge of perfect squares to estimate square roots? So the first question is, what are perfect squares? When I was a student, when I was in your seats, my preferred method of doodling, because I have no artistic talent, was to make literally perfect little squares. I would just make them and I would fill them in perfectly, and that was how I doodled in class. So I would have notebooks full of these perfect little squares. But that is not what I'm talking about for perfect squares in math. Perfect squares in math mean numbers that are another number squared. So for example, 1 squared, which as you hopefully remember means 1 times 1 is 1. So 1 is a perfect square. 2 squared is 4. 4 is a perfect square. 3 squared is 9. 9 is a perfect squared. 9 squared is 81. 81 is a perfect square, and so on. Perfect squares. Now, notice I have them all written over here. These are all the perfect squares, and these are the ones that it would be a really good idea to have memorized. These are ones that are going to come up many, many times. So you should know off the top of your head, 121. I know that that's 11 squared. Here's where it's going to help you. We are moving into square roots, and square roots is going backwards. So on the previous slide, I went forwards. I knew that 3 squared is 9. But with a square root, when I take the square root of 9, I'm going backward. I'm saying, hey, what number did I square to get me 9? And if you remember from last slide, we said that 3 squared was 9. So moving backward, the square root of 9 is 3. So square roots are moving backward. If I took the square root of 36, I would have 6. If I took the square root of 81, I would have 9, and so on, because I'm moving backward. I'm saying what number squared gives me this number. So let's evaluate the following expressions that magically popped up while I was doing those other square roots. First of all, I have 3 plus the square root of x when x equals 9. So let's plug 9 in for x. 3 plus the square root of 9. Now, order of operations, PEMDAS. What does the square root count as? I don't see an s anywhere in there. Well, I do, but I already know that this s is subtraction. The square root counts as an exponent. And the reason it counts as an exponent is because, and you do not have to remember this, but the square root of 9 happens to be the same as 9 to the 1/2. If you take algebra with me, like 2.5 years later, we will get to that and we'll talk about it. For now, just know that square roots count as an exponent, which means I need to do them first. So in this problem, 3 plus, okay, the square root of 9 is 3, because I know that 3 squared is 9. And then finally, 3 plus 3 is 6. Let's go a little bit faster because you guys are so good at this. 4 times the square root of 49. Let's see, the square root of 49. What number squared gives me 49? It's 7. So 4 times 7, and 4 times 7 equals 28. I should be boxing my answers because I'm a good student. Finally, this problem, -3 times square root 121 minus 7. The square root of 121, this is a tricky one to remember, but it is 11 squared. So -3 times 11 minus 7. I know I have to do the multiplication first, so -33 minus 7. And when I have the same sign, the rule is add and keep. So -33 minus 7, -40. Awesome. Square roots, super fun, not too bad. Except, oh wait, I'm going to be asking you to estimate the following square roots, because here's the deal. If we're taking square roots of all these numbers over on the left-hand column, we know easily what they are. We have them memorized, it's good. But what if I have square roots like this? I'm going to be giving you a couple different square roots that do not show up over on the left. For example, the square root of 5. What squared gives me 5? I don't know. It's not over on the list over here. 5 is not a perfect square, but I can estimate it. So we're going to see how good Mr. Gregory's estimating skills are today. And here's how I'm going to do it. I know that the square root of 4 is 2, and I know that the square root of 9 is 3. Shouldn't the square root of 5 be somewhere in between there, right? Because the square root of 4 is 2, the square root of 9 is 3. I know that the square root of 5 is somewhere in between the square root of 4 and the square root of 9. So it's got to be in between 2 and 3. I'm going to estimate, let's go 2.3. And if I plug this into my calculator, the actual square root of 5 is 2.236, blah, blah, blah. It goes on from there. So I was pretty close. Actually, I was really close. That's pretty impressive. So the square root of 5, it's this decimal that goes on forever in actuality. But what I'm going to be asking you to do on quizzes, since I'm not letting you use your calculator, is estimate it. We can do that by finding out what other two square roots it's in between. Want another example? I know I do, because it gives me another chance to estimate, which is what I do for fun. The square root of 60. Okay, I know the square root of 60's got to be in between the square root of 49 and the square root of 64. Square root of 49 is 7. Square root of 64 is 8. So square root of 60 is going to be somewhere in between 7 and 8. I'm going to go with 7 point, let's go 8.5. And when I put it into my calculator, the square root of 60 is actually 7.746. And it goes on from there. Oh, I messed that up. 7.746. There we go. Okay, so not as close as the last one, but I think I can be forgiven. I'm only a tenth off. Pretty good. Last problem. Square root of 135. Okay, this has to be somewhere in between the square root of 121 and the square root of 144. I know the square root of 121 is 11 and the square root of 124 is 12. I'm going to say that this is, let's see, 11 point, let's go with 6. Let's see how I do. And when I put it into my calculator, the square root is a whole 11.619. This makes me happy. So I'll just draw a nice little smiley face there. Okay, so just a quick reminder of what we did. I figured out an estimation for the square root by finding out what two it was between. Over here in the actual, this is what it would actually be if you put it into your calculator. These are all never-ending decimals. They're never-ending. So I need to teach you about a new category of numbers. The categories I've taught you so far were whole numbers, integers, and rationals. And if you remember, we said that whole numbers were things you could count on your fingers. Integers were those, but also negative numbers that you can count on your fingers. Rationals are those, but also fractions and decimals. And I kind of left it at that. I just said fractions and decimals. But as it turns out, there's this other category called irrationals. And irrationals are decimals that never end and never have any pattern. So here, this decimal ends, all right? Or even, let's say I have 0.3 repeating. That's a pattern. As long as I have a pattern, I can turn it into a fraction, which makes it a rational. But irrationals are like the square root of 5. If you put the square root of 5 into, say, like Wolfram Alpha or something that will give you just really, really high numbers of decimal places, you'll find that it's a decimal that just goes on and on and on and on, and it just has no pattern whatsoever. So I have absolutely no way of turning this into a fraction. It is irrational. All of the square roots that I cannot turn into whole numbers, all of the non-perfect squares, happen to be irrational. So all these things that I'm listing. There's another really famous irrational number, which is pi. And pi is 3.14159. I kind of forget it from there. But the point is, it's a never-ending decimal. It goes on and on forever without a pattern. So irrationals, they do not include rationals because rationals have a pattern. Irrationals do not. It's this whole other category of numbers. Rationals and irrationals together make up all of the real numbers. All right, that's all I have for you today. Let's look at the summary. First of all, taking a square root is the opposite of squaring a number. So since 3 squared equals 9, when I take the square root of 9, that's going to give me 3. We can estimate a square root by figuring out what two perfect squares it is between. So if I had, say, the square root of 7, I would say, oh, that's between square root of 4 and square root of 9. Therefore, this has to be somewhere in between 2 and 3. Therefore, it's something like 2.6-ish. Thanks for watching.